Hello, everyone. Thank you for coming. My name is Josh Blake, and I'm a consultant with InfoStrat in DC. And I've had the extreme fortune and opportunity to work with Microsoft Surface for the past 2 years. And we've done a lot of different multi-touch projects with Surface. And we've also since moved on and done some projects with Windows 7 multi-touch with WPF 4. So what I wanted to do with this session was kind of distill down the experiences that we've had and the lessons learned and combine it with some of the research that I've done about natural user interfaces and just talk about some concepts about NUI and also how we can apply some of those concepts with Silverlight and WPF4. And of course on Monday they announced the download for the Windows Phone 7 SDK, so I had to download it, and now we have Windows Phone 7 in my presentation as well. If you're tweeting, then you can use the MIX10 NUI hashtag. And at the end of the session, so I'm also writing a book on multi-touch on Windows, so at the end of the session I have 6 vouchers to give out to the first 6 people who ask questions, so stick around for that. So when I was preparing for the session, I was thinking about how I'm going to be talking about natural user interfaces. And you guys are probably bored a little bit with PowerPoint. So I wanted to walk the walk a little bit and create a multi-touch natural user interface presentation as well. So this is not PowerPoint. This is a custom multi-touch application that I made on Windows 7 with WPF 4. So I'm going to be kind of using it, moving around as I talk. So rather than be PowerPoint, this application is called Natural Show. And we're going to be presenting in a very fluid way, moving between concepts. And I chose the word natural because, of course, we're talking about natural user interfaces. So the first part of this, let's kind of get into the details of what is a natural user interface and kind of explore some of these ideas. So with the command line interface and graphical user interface, those evoke very strong images of what you interact with, the input technology, the keyboard and the mouse. So an initial impression for natural user interface might be, how do you interact with it? So we might be thinking about NUI in terms of input. So you might think if you're using multi-touch or voice or motion tracking like Natal or Stylus, then it's a natural user interface. Well, it's not completely true. With NUI, NUIs do tend to use these technologies, but just because you use these does not make it a NUI. And the perfect example is you can't just take a touchscreen, use a GUI app on it, and it doesn't automatically become a NUI. The GUI app's designed for mouse input with the WIMP metaphor. It's not natural. It doesn't fulfill the promise of NUI. So if NUI is not just about the input, not just about the interface, then what is it about? Well, it's really about natural. So let's talk, what is natural? And Bill Buxton has some great thoughts, and a lot of my ideas and research are based upon his. So we agree on a lot of things, and I wouldn't venture to disagree with Bill Buxton. So let's start with a quote from him. He said in January, "An interface is natural if it exploits skills that we've acquired through a lifetime of living in this world." And when I saw this quote, it kind of spoke to me. It was really interesting because it kind of frames the debate around what skills people have, and also the fact that these skills that we're using in the interface are not things that you just learn for the interface. It's things that you've learned because of the fact that you're human. You live in the real world. You have human-human communication, both verbal and nonverbal, a lot of skills around that, and human-environmental interaction. interacting with objects, moving them around, changing things in your environment. So there's a lot of skills that your users have just because they're human. And this process of building these skills starts very early on. So they're expert in a lot of things. So I think it's important to talk about reusing these skills. So when I was thinking about this, I identified that there's really two categories of skills. So let's talk about those. There's composite skills and simple skills. Composite skills are those that are dependent upon or made up of several other skills, and you combine those in a particular way to do something. The composite skills tend to take a long time to learn, or you have to practice, and they're fairly complex. Examples of composite skills are playing a musical instrument, or programming a computer, or even, I would argue, a lot of the things that we do with GUIs today use composite skills. So an example of navigating the file folder hierarchy. And this is something that for you and me is very second nature. And you would think, oh, that's easy. Well, it's easy because we've already invested in the skill at some point in the past. And we know how to use it. And after we made that investment, it's much easier to use it. The effort goes down once you've learned it. But for new computer users, and a lot of people for a variety of reasons, this is a hard thing to learn. You're coming to this screen, this image, and you think, well, how do I interact with it? Well, those are folders, and that builds upon the desktop metaphor with folders and files in them. But it's not quite the same because you have folders within folders ad nauseum. So you have to learn a little bit about the metaphor, and you have to learn about how do you interact with it. Well, these little triangles you can click to expand and contract. All right, and then you can click on the folder name, and then something somewhere else in the interface changes. And for a new user, it's not always clear why, but eventually people learn this skill and make do because that's what we have now. One aspect about composite skills that's important to consider is that it's difficult to take a composite skill from one context and reuse it in a different context. So aside from navigating file folders, we don't really use the skill and the effort that we put into learning the skill anywhere else. Some applications use tree views and hierarchies in a similar way, but it's not very widespread. It's hard to reuse it. And a lot of times when they reuse it, it has its own subtleties. So in contrast with composite skills, simple skills are very easy to reuse in new situations because they're based upon the innate abilities that we have. They don't have a lot of complexity, and they don't have a lot of requirement of learning some domain knowledge like composite skills do. So simple skills, you can reuse them from one context to another very easily, and you can also learn them usually through basic observation or very basic prompting. So an example of this, I use a real-world example. This is just a very crude drawing of my second daughter, Lily. And one of the games I play with them is sniffing flowers. And when I was thinking about simple skills, I was thinking about the first time I played this game. I taught her the game. I was holding Lily, and I had a flower, and I said, you want to sniff the flower? This was when she was about 11 or 12 months old. And so I leaned over, and I wiggled my nose, and I sniffed. And I maybe demonstrated another time, and then I said, you try. And she leaned over, she sniffed, and she copied the skill. And so now, new skill, achievement unlocked. Now she can use this skill in a lot of other places. So then she goes around, she's sniffing other flowers, she's sniffing food, she's sniffing her clothes and toys. So these simple skills that easy to learn, easy to reuse, we can focus on those in our interfaces. So now we've talked about what natural is. So let's kind of put this together. And in my book, I was challenged myself to come up with a definition of natural user interface. And this is a working definition. I actually changed it last night based upon some of the things that Bill Buxton had said. So it's still evolving. But a natural user interface is a user interface designed to reuse existing skills for interacting directly with content. And so there's 3 important parts to this, so let me go through those real quick. So there's an emphasis on design. The fact that if we're going to create natural user interfaces, we have an opportunity to create an interface that is best suited for this particular task, with this particular form factor, and a particular environment, with a particular type of content. And what's best for all of those things may be different from anything else that we've done before. And so instead of reusing patterns and kind of having stale interfaces with natural user interfaces, as long as we focus on reusing existing skills, we can design the interfaces so that users can become instant experts. So the design aspect would recognize the role of design in creating the NUIs. And we designed to use the natural user the reuse existing skills. And what do we do with this? We interact directly with content. And so the direct interaction with content, you focus on the content rather than any Chrome or any extraneous controls. The content itself, what the data or the information that the user wants to use or change, should be the majority of the interface. So like in this interface, and I'll show you later behind the scenes a little bit, but I'm interacting directly with this. I'm not using any other controls. There's actually only one control I'll show you in this whole interface. So what's so great about direct? So with direct, there's 3 aspects to directness. There's physical proximity. So how close is your body action to the thing that you're interacting with? There's temporal proximity. When you make an action, is the response, the feedback immediate, or does it happen some other time? And there's parallel action. So when I move my finger left or right or any other way, or pinch manipulation in and out, is the interface responding in a parallel way to the action that I'm performing? So if you design direct interactions, you kind of get 2 extra features, 2 extra bonuses. And that is that your interactions become high frequency and contextual. So high frequency means the interaction size with a direct interaction, the chunk size is much smaller. And so you can have a lot more of these interactions. And the interactions is both the user doing something, some input to the interface, as well as the feedback to the user from the interface. It's interaction, it comes both ways. So the user can get a lot more information in smaller bite-sized pieces that they can process very quickly. And it really changes the whole experience. And direct interactions are contextual because I'm interacting with this content right here. And I'm not presented or bombarded with all the different things that I could possibly be doing in this interface. And this is in contrast to a lot of GUIs that at one point the height of usability was claimed to be 2 mouse clicks to get anywhere from anywhere. So you have in client apps you have toolbars and cascading menus, so you can do anything from any place. And in websites you have these hierarchies that so you can very quickly get to anywhere. But maybe that's not the best thing for usability. Maybe it's more, instead of the quantitative aspects, it's more about qualitative. So what does the experience feel like? And so the direct interactions with high frequency and contextual are a lot different. So as a real-world example, let's pretend you're cooking. You have a pot on a stove, throw some ingredients in, you heat it up, and you have a spatula and you're stirring it. And so you're interacting with the content. In this case, the food is the content. And as you stir it, you scrape the bottom, and you get a lot of feedback, very quick, high frequency, small feedback. You can feel is it sticking to the bottom, so you don't want it to burn, so you can stir it around, and as it cooks, you get a feel for the consistency as it changes. And then this interaction with the cooking is contextual because you're not bombarded with all the other things you could possibly be doing around the house. But since it's high frequency interaction in the real world, if you want to change what you're doing, you quickly move over and go to a different room and do something else in that context, and you come back and take a look at how your meal's coming. So to contrast this with GUI and how we do things today, I made this kind of maybe goofy mock-up of a little wireframe, an application, Cooking Pro 2000. And so you can pick the ingredients, and you can use the buttons and move them into the pot, and then select the cooking time and how often you stir. And then it's a wizard format, so you click Next, you have a progress bar, and maybe you have a status update or two. And then at the end, your meal was burnt and thrown out. Helpfully, you can retry. So this seems like an absolutely goofy way to cook something. This is totally ridiculous. But the fact is that this is the status quo with GUI interaction. And this is how we're interacting today with a lot of things. So what motivates me is what's the possibilities of NUI to change how we interact with computers. And I'm hoping that you guys will be part of this kind of NUI revolution, taking us into the next generation of interfaces. So we now have a pretty good idea, or at least a starting point for conversation of what the natural user interface is. So with GUI, there's the WIMP metaphor, Windows icons, menus, pointing devices. And a question that comes up a lot is, what is the equivalent of WIMP in NUI? So let me talk about what I think the equivalent of WIMP in GUI is, in NUI. I believe it's OCCM. Objects, containers, gestures, and manipulations. And the concepts behind this were developed by a fellow NUI enthusiast, Ron George. And the only thing that I'll take credit for is the acronym, the order that the letters go in, and the link to Occam's razor, which is kind of a beautiful double meaning. A very crude definition, Occam's razor, the most simple thing, is most likely correct. And this kind of links to what we're talking about with NUI and simple skills and the simple interfaces. So let me go through briefly these different components of Occam. So objects are metaphors for your content, the basic unit of content. So users are used to interacting with objects in real life. They can move them around. They're permanent. They don't disappear when you're done using them. When you put them away, there's a continuous transition to somewhere else. So we can create the content in your interface as objects. So here's a little interactive part of the presentation. So Natural Show is real. It's not just mocked up, hard-coded for this presentation. I created the actual tool to create presentations, and then I created the presentation with the tool. So it's probably hard to see on the projector, but on the bottom right, there's a very, very transparent icon, a little lock icon. And if I bring that up, this is my lock bar. The save button is the only real control, the one button in the whole interface. And I can move this around, and these are just images pulled from a directory. So if I want to, and when I unlock this, I can interact with the actual elements. If I want to do something, I can bring that out, change it around. Let's bring out this one, and maybe one other, maybe an old mouse. So we can interact with these objects, and we can move them. And if I when I brought them out, it's a fluid transition from an inactive state to an active state, and we can do the same thing going the other way. So let's lock that. So now I I just interact with the interface, the presentation layer. So containers are metaphors for the relationship between objects, or relationship between content. So as you have different pieces of content in your interface, they inevitably have some kind of relationship from one to the other. So you can help the user understand that relationship by the design of a container. So this could be very basic. So this is a zone, I call it. So you could put in a container, and this is just logically grouped. Or you could, if you have content that is spatially related, you can present that on a map. So the map metaphor will help the users understand that, look, here we have 2 data points. We have InfoStrat's location in DC and where we are in MIX. And by the way, this is the InfoStrat VE control, the free open source Bing Maps 3D control for WPF, and it has multi-touch and everything. It's available on Codeplex. So the map, this container of a map, helps you understand what's the relationship between this data point and that data point. So objects and containers are the 2 basic elements of the interface elements. And you can build upon those ideas your own specific metaphors for specific situations. But how we interact with those is through gestures and manipulations. So I highlight the difference between gestures and manipulations because it's very subtle, but it's very important when you're designing these interfaces and when you're implementing them in code. So, and there's a lot of overlap between them, so sometimes it's confusing. So gestures are body motions that convey meaning. So if you ask me, where's the restroom? And I extend my arm and I point my finger, this body motion has meaning. The restroom's over there. And these are based off of human communication and nonverbal communication, pretty much. Gestures are discrete, which means that you have to complete the whole action before the meaning is there. So if I only extend my arm halfway, you don't really know anything about what I was trying to tell you. I have to complete the gesture, and then you can interpret it and then take action upon it yourself. So in contrast, manipulations are based upon the human environmental interaction. And so when you have an object and you're moving it around, you have something you want to do, you can do it yourself. You change the object, you move it, you do whatever you need to do with it. So manipulations are direct, and this is where your parallel action and spatial and temporal proximity come in. And they're continuous. So you have continuous feedback. So every time I move a little bit, this interface gives me some feedback about it. Whereas with gestures, the feedback doesn't come until the end when the message is interpreted. So we've talked now about natural user interface and Occam. So let's transition to talking about code and how we can actually implement some of these ideas. And so for the designers in the audience, I hope that what you get out of this next part is kind of an understanding of what the developers have to work with on the different platforms. And then developers, you guys have learned a little bit about the UX, so kind of a little bit cross-training and understand each other's language. So multi-touch on Windows. Let's talk about this kind of stack. So we have a lot of different types of hardware, different interface touchscreen types. Some of them are optical or capacitive or resistive, different form factors. And Windows 7 is the platform that kind of standardizes all of that. All these things talk to Windows 7. And if you have Windows 7 as your client, your OS, you have 2 options that I'm going to talk about for a multi-touch API. It's WPF4 and Silverlight. And of course, WPF is for client development, and Silverlight's for web. Now, of course, you have to have the Windows 7 with the web component of Silverlight to have this multi-touch experience. But on either one of these, you can build your next killer NUI application. So before we jump over to the code sample, I want to talk about what the two main types of API are. So we have raw touch and manipulations APIs. Raw touch gives you all of the raw information about the fingers that touch the screen and when they move and when they're released for every single finger, every single event. It's a lot of information. And this is useful for when you need to do something on a per finger basis. So in this application, I used the raw touch APIs to create these little auras that help you see what my fingers are doing, even though you're not looking over my shoulder at my actual hand. So every time my fingers touch, I can get that information and present it. Now, raw touch is good, but a lot of times for the types of things you want to do with NUIs, you want to work on a higher level. So that's where the manipulations comes in. The manipulations APIs aggregate all the contact information, the touch points, and does some complex math and matrix transforms and different things behind the scenes and presents you with a higher level understanding of what these contact points are doing in aggregate. And there's three types of information that it gives you. It gives you translate, rotate, and scale. So regardless of the number of fingers I use, whether it's 1 or 2 or 3 or 4, I translate in my application behind the scenes. It only worries about what all the fingers are doing in aggregate through the manipulation. And in the same way, it can give me information about rotation and about scale. So as I expand out some fingers, I get some information about how the whole set of fingers is moving. So let's switch over to the code and let's show you some stuff. All right, so I prepared 2 programs to show the raw touch and the manipulations API, and I prepared them on WPF and Silverlight. And like I mentioned, I kind of went real quick and prepared them on Windows Phone 7 as well. So what I want to do, I'm not going to go too deep into the code or the API. There's a lot of resources out there to learn that. But what I want to do is really highlight what are the differences between these platforms, what's the level of effort required to create interfaces, multi-touch NUIs with them, and maybe that can help inform your choices about how you start your projects. So let's start with TouchGrid. So TouchGrid uses the raw touch API, and I have these dots that are, each of them are separate controls, and the control subscribes to the touch enter and touch leave event. And it uses that to activate or deactivate and make this little animation. So the raw touch API in WPF4 is very similar to the mouse in style. So you have touch down, touch up, touch move, touch enter, touch leave, all stuff you see from the mouse. But with the touch API, you get multi-touch. So I got this one, and all these events are just firing whenever the fingers and the contacts move, and you can do all kinds of crazy stuff. So behind the scenes, let's show where this magic occurs. So I mentioned this is a control. When the template is applied, I get the container, basically the outermost UI element. And when I set this property, it subscribes to the touch down, touch enter, and touch leave events. And touch down and touch enter both just set the active to true, and touch leave sets it to false. And it updates the visual state using Visual State Manager. So it's very simple. It's a couple events, you subscribe to them, then you take action upon them. So this is great. This is very simple. So the second program I have is ScatterTouch. So kind of the hello world of multi-touch is the scatter view. And the scatter view is where you can have an item and you can pan it around and scale and rotate. So that's basic, and we've all seen something like this. And I also have the aura visualizations, the same from Natural Show. So behind the scenes, what's going on with this is, I'm moving the XAML first. So we have this rectangle, and this could be any kind of object. The manipulations, both the manipulation and raw touch API are built into the core framework. Any UI element, content element, or UI element 3D has all of these events that you can subscribe to. So to start our manipulations with this rectangle, I set is a manipulation enabled equals to true. And if it's true, then whenever a touch point touches or bubbles up to this element, it'll capture that touch point, and the manipulation API will take care of all the math behind the scenes and then start firing events for you. And for this application, I just needed 3. There's a couple more for manipulations. I have manipulation delta, which is called every time something changes about the manipulation, any of the fingers move. I have manipulation starting, which is called just before the manipulation starts up, when the first contact point is captured. And it lets you set a couple parameters that you might need to change per manipulation. And manipulation inertia starting, which is called just after the manipulation completes, which is when your last touch point is raised, and lets you set up some parameters about inertia. So the inertia, so let's take a look at this delta. So we have manipulation delta vent args, and most often you'll use the delta manipulation property. And what that gives you is what we talked about, the translation, the scale, and the rotation. And there's also expansion, which is a different way to present scale. It's just a different measurement scheme. So what I do in here is I take the delta, and I'm using a matrix transform, and I translate it, and I rotate it, and I scale it, and then I set it back to the render transform. So all the movements of that UI element, the rectangle, are just based upon render transform, and the render transform is updated based upon the manipulations. Then down here in inertia starting, all we have to do to enable inertia is tell it what deceleration value we want to use. So the translation will decelerate at a certain rate, and then it'll call the manipulation delta again. And so we can use the same logic for both. And you can tell if you're in inertia by checking a flag here. And in this case, it also does boundary checking to make sure that we don't fly right out of the screen. So I'll just show the inertia aspect. So I can kind of throw it a little bit. And if I go too far, it'll stop at the edge of the screen. So those are the 2 programs in WPF. I took the same programs and I ported them to Silverlight. So I'll show just very quickly that it does the same thing. So I have this running in Silverlight. This is in the browser. This is touch grid. We have our touch points. All this magic is going on. So the behavior, we can achieve the same behavior, but the code is not the same because the API in Silverlight is different. So let me just show you that real quick. So instead of the touch grid, the touch grid dot having the mouse enter or touch enter and touch leave events, all Silverlight provides us out of the box is touch.frameReported. And that event is called whenever any contact point changes in the entire Silverlight application. So you're kind of left to do whatever you need to do with it. You're a little bit on your own. In this case, what I do is I iterate through all of the touches. I use get touch points. I iterate through them. I do hit testing to figure out which touch dot I want to send the event to. And then I report a touch, So this is new in the Silverlight version, and it just sets whether it's active or not. And it still uses the Visual State Manager. So some of these, like the Visual State Manager, are pretty much the same from WPF to Silverlight. But it took a little bit more work to get the multi-touch input working. And it wasn't too bad, but this is a trivial example. If you're doing a more complex application, you might have a lot more effort. It depends on what you're doing. So there's a difference in the level of effort required with doing the same thing in Silverlight versus WPF. So we also have the scatter touch sample. So again, Silverlight in the browser, same thing, even have the auras, and also have the inertia and the collision detection. So same thing going on. So the behavior is exactly the same in this case, but I mentioned that the only thing that Silverlight gives us is frame reported for the raw touches. So how do I do the manipulations? Well, you can't really. But fortunately, the Surface team released a Microsoft Surface manipulation sample for Silverlight, or some long version of the name, but it gives you this DLL that system.windows.input.manipulations. And that gives you, let's see over here, that gives you the manipulation processor and the inertia processor. But it's up to you to take the frame reported points and then do any kind of hit testing or whatnot, and select out which touch points over this element do you want to do a manipulation with, feed it to the manipulation processor. It does the complex math behind the scenes that aggregates and tells you the translate, scale, and rotate, and then it sends back the events. So in this case, we have the manipulation processor events. The names are slightly different. And we have this helper library that also came with the Surface team sample. Basically, we take the frame reported, and it ends up going into here, and we feed it to the manipulation processor. And I'm skimming over it fairly quickly, but and then the manipulation processor delta, we update the transformation. So this logic actually is pretty much the same, or at least the same strategy from WPF to Silverlight. We use the render transform. And then we have inertia as well, although you have to run your own timer to figure out the inertia. So manipulations are even more difficult in Silverlight, but you can do them with the Surface manipulation sample. So I've showed the WPF and Silverlight, and so what I want to do is show the Windows Phone 7 equivalents. And so WPF and Silverlight, they behave exactly the same. I couldn't quite get them to be exactly the same in Windows Phone 7, but I'm going to show you anyway. So we have the touch grid, perhaps, loading symbols. We have the touch grid in the Windows Phone 7, and I'm touching it with my fingers on the screen. We have the same kind of behavior here. Unfortunately, in Silverlight, we don't have access to all the touches, only the first one through the mouse down, move, and up events. So I couldn't do the multi-touch aspect here. X and A has the raw touch information, and I understand that that's something that they're working on for Silverlight. So we kind of have the same behavior here going on behind the scenes. And the code was pretty much the same. We did use let's see where we get them. We did use the mouse enter and mouse leave events on the touch grid.control, and that updates the Visual State Manager. And we also have a partially working version of the scatter touch sample. So it'll display the rectangle, and then we can pan it around. But from talking with here we go. So I pan that around and so on. I couldn't quite get the scaling to work. The values were a little bit weird. I'm not sure if it was my lack of understanding of what's going on, or maybe a bug, I'm not sure, but we at least have the panning. Rotation is not supported in the hardware on Windows Phone 7, so you can't get the manipulation rotation information. But the Windows Phone 7 does have the manipulation processor built in, so at least it has that benefit. So let's see. So we do have we set up the manipulation delta on the rectangle element from XAML, and inertia as well, and all the logic is pretty much the same. So kind of showed the same thing running on all three platforms: client, web, and mobile. And I've tried to highlight the differences between the APIs and the level of effort for developing one versus the other. The only other thing that you probably want, so the WPF API, the WPF4 Touch API, is based upon the Surface SDK. And the Surface SDK is great. It's really first-class multi-touch API. And WPF improves it even further because it's integrated into the core framework. But WPF does not have all the controls that the Surface SDK does. So the touch-aware buttons and scroll bars or list boxes and all these other things. So it doesn't have that built in. But the Surface team is working on the Surface Toolkit for Windows Touch, which will bring all those controls from the Surface SDK and make them available to Windows 7 and WPF4. So that's not ready yet, but if you're getting started with creating WPF multi-touch apps, then definitely look for that when it comes out. So I mentioned at the beginning that I'm working on a book, Multi-Touch on Windows, NUI Development with WPF and Silverlight. And this is due out fall 2010, but it's available now under the MEET program, Manning Early Access Program. So if you're interested in some of the ideas that I've been talking about and really in-depth details about how you develop these apps and other information for both WPF and Silverlight, then I encourage you to go to the website and take a look. Chapter 1 is free, and if you pre-order either the ebook or the print book, then you also get the MEEP, which means you can read the chapters as I write them, and they'll send you emails whenever I update a chapter. Special for MIX, 35% off with MIX10 MT, expires March 31st. So with that, wrapping up, I wanted to thank you guys for coming to my session. This is my contact information and my blog. I want to encourage you to go to Mario's session on Surface and Touch this afternoon, and we'll open up for questions. And so I have the vouchers for first 6 questions.
That library you mentioned, is there a name for it so that we can get it? The Surface library?
The Surface Toolkit or
yes.
the Silverlight one?
The one the Surface team is working on to take the controls in the Surface SDK that aren't in WPF.
It's called the Surface Toolkit for Windows Touch. Thank you.
So I think I already asked you this offline before, but just officially, I'd like to ask if your Natural Show app could be something that you could make available.
So I have not decided what I'm going to do with it. Right now, I'm not making it available, but I am going to make all the demo code, the touch grid and the scatter touch available. I'm going to try to put it on the website for this session.
Okay, cool.
So, as you said, right, the situation in Silverlight right now is not that good. And I think we're at a time right now where the Silverlight team is going to work on future things. Would you say that the situation in WPF now is where it's at, and this is what Silverlight should reach, or do you wish for even further improvements in Silverlight multi-touch?
So that's a good question. I don't have the information, and I wouldn't bother to speculate on what the Silverlight team is going to do, but if you're asking what my opinion, my desire,
that's what I'm asking.
Yeah, I'd like to see the Silverlight be on par with WPF, with a manipulation processor built into UI element, right in the core of the framework, first class. I'm sure there's some things that can be improved, maybe better gesture recognition support, something along those lines. But the WPF4 Touch API is pretty good, and it's going to enable a lot of really interesting apps. And so.
Mm-hmm. Okay, thanks.
Yeah.
Can the WPF4 multi-touch be used across multiple monitors within the same application, multiple multi-touch monitors? And if so, do you have any experience with that? And what the hurdles might be?
So WPF you can use across multiple monitors, but that's tricky. I haven't tested that, so I don't have an answer. That it would be kind of tricky. Even you'd have to have both monitors be touch enabled. But I don't really have an answer because I haven't tested that. I have the tablet, not several. Although if you want to, if you have a couple you want me to test out, then I'll do that.
All right.
Hey, how you doing? Thanks for the VE control. We totally love it.
Oh, thank you.
Multi-touch, NUI is dominated by multi-touch right now, but I think that we would all agree that the evolution of that really needs to be progressing into the spatial user interface. And I would ask you to postulate on application of the objects, containers, gestures, metaphor into a spatial UI, and then further postulate, theorized on what toolkits we might be available to application developers to apply those things in a spatial UI, and what we're going to do. We're interacting spatially with two-dimensional content and furthering the capability to have a 3D UI and a 3D gesture recognition in the application. And real world, what tools are we going to use and what might be available, whether it's in Windows 7 or whether it's a subset of XNA or WPF?
Sure. So great question, very forward-looking. So Project Natal is, you guys are familiar with it for Xbox, and I'm excited by if that is made available. I don't have any information. I'm not Microsoft, but if that's made available for non-gaming scenarios. And so Occam really applies for that as well. So you can have objects in your screen that you interact with using your body motion in air, and gestures and manipulations apply for spatial movements as well, motion tracking. So suppose that you have maybe an avatar hand that's tracking your hand, and you grab an object and you move it around, you can manipulate it, or you can also have the gestures and flings of your arms and flailing them wildly. So that still applies across the board in any of the different input technologies. The second part of your question, I guess, was about the frameworks, and really I don't have any idea. I know that when you start to think about 3D body motion, it's going to become more complicated than just a basic manipulation processor. But I know that there's a lot of really honest geniuses in Microsoft that are working on that problem.
Hi, I'm just wondering, my experience is that the feel of interaction with Surface is much better than on Windows 7 with multi-touch, and is there any way to manipulate the sensitivity of it on Windows 7 so it's less exact, so to speak?
Sure. So the feel of the interaction is very dependent upon the hardware. So Microsoft Surface is great because it's, you have the 52 touch points and really highly responsive input technology using the optical sensors. There's an infrared camera. And the currently available multi-touch monitors, like this one, is capacitive, and they really vary in quality right now. I know that in the future they're getting a lot better. And there's a couple in the Commons. I'm not sure the manufacturers, but they work really well. They're expensive right now, but we know technology gets cheaper over time. So, but when you're creating the applications, maybe think about specific deployment. The specific hardware and the form factor is important. And you have to think about and you test on the types of devices that you'll actually use. The other aspect about the feel of it is the performance of the application. So a lot of time this week, I found when I was building out the rest of the presentation, it was starting to lag behind when I was starting to manipulate it or move around the items. So I had to work on the performance of it, make sure that it doesn't block any of the user interface. If it does, then it really ruins the experience. So that's definitely a focus on performance. And really, it's there's design problems and there's development problems. So this is one of the development problems challenges.
Great, thanks.
Hi, what are your ideas on affordances for touch, and how do you encourage touch with NUI?
So affordances, good question. So affordance is when an object looks like it can be touched or changed in a certain way. And to be honest, this presentation I didn't do much about affordances, just try to get the basic thing out. But you do need to think about, in the design process, how are the users going to know that they can touch the application? And that's a problem in the beginning of, in the beginning of this kind of change from GUI to NUI and multi-touch. How are the users going to know that they can touch this application? And when they know that they can touch it, how do they know how they can touch it? How do they manipulate it? So you do need to think about, does this visual presentation of an object or a container or whatever in your interface, is the visual presentation representative of how the interaction is? So it's definitely something that you have to consider when you're designing the application. All right. Thank you guys for coming. If anyone else wants to chat, I'm going to go over to the Xbox Lounge. We can chat afterwards. And please take a look at the book and give me feedback. Thank you.